Hello, hello, hello. If you're watching this, you missed day 1 of our week 12 Computer Science Principles lecture. Let's go ahead and get going here. We are talking about several things today. Compiled versus interpreted, for ways we can have code become binary and actually be executed by our computer. We continued our exploration of variables, and we went ahead and did an assignment involving the variables. So there's 2 assignments we did today. One was a kind of warm-up like, very simple 5-point practice/participation grade, which is due by midnight tonight. Please make sure you get that into me, compiled versus interpreted. And the other one being variable practice, which is due on the 18th, and that is to be done in code.org, lesson 3 of unit 4, right here. So please make sure you do that. Now, there is also a project coming up. It's already posted if you want to check it out, and that's going to be due Friday the 20th, and that's going to involve you recreating an application. All the instructions are inside code.org as well, and there's a handout posted on MIME-CPS. You should be able to write programs that use variables and expressions with support from sample code, debug programs that use variables and expressions, correctly employ comments, and differentiate between compiled and interpreted languages. So let's go ahead and get started with that. How does your computer convert your program into what you see happen on your screen when you run it? This video right here explains it very well. Please check out this PowerPoint and watch the video. It's about 5 minutes long. I'm not going to play it for you, but what I'd like to do is just fast forward here to a little pros and cons column. There's 2 ways you can go. One is compiling, the other one is interpretation. Compiling takes your program and transforms it down to a binary file that only your computer can read. So it's good for making it so no one else can read your code. But the problem is you need a different binary for different operating systems. So you have to recompile depending on what kind of machines you're on. Now, once you've got it compiled, it's really fast to execute, so that's a big plus. But it's really slow for you as the developer to get it to work because you have to, every time you make a change, recompile it, and that takes a while. The opposite is true for interpreted languages. You can run it right away, but if you want someone else to be able to run it, you got to give them your source code, which is a problem if you don't want them to see what's going on there. There's a thing called bytecode, which allows you to have kind of the best of both worlds. Your code is a little bit compiled, a little bit interpreted, and together you get some benefit of both, but obviously you're not going to go quite as fast as a fully compiled file, and you're not going to quite get the advantages of interpreting completely. So it's a happy medium. All right, moving on. Let's go ahead and talk about variables. So last time we left off talking about variable assignment and how you can do some computation with variables. Let's keep going. Here's some more typical behavior you might be interested in. If you have a variable and you'd like to do some kind of evaluation and then stick that value into a new variable, this is allowed. So here we have a variable called kit. Kit gets 1. Variable called boo. We want to set boo equal to kit plus 1. This right-hand side expression will always get evaluated first, no matter what you have over here. Think of there being parentheses around all this. In fact, you could put parentheses around there if you want, but even without parentheses, you need to know this is the expected behavior. Everything gets calculated, and the expression, or assignment right here happens last. And this expression is whatever the result of it is, placed inside here. Note that if we go ahead and stick 5 inside kit, the 1 is going to get lost, kit gets 5. Boo does not change. These variables are not connected in any way. The program is sequentially executed. This line already happened. We do not get to go back to that line and do it again just because we did something different to kit. That line is gone. We're not coming back to it. So be aware of that. The variables do not get magically linked just because you referenced one inside of an assignment. So here I have some examples. You can try these on your own. These are the final results. Some takeaways. Numbers and strings are 2 different types. As soon as you convert a number to a string by, let's say, concatenating it to some word, it will be a string forever. So be careful. Don't try to divide a string by anything. It will not work. Expressions evaluate to a single new value. When variables are expressed, they make a copy. So be aware of that. It doesn't change the original variable. Variables are assigned a new value. If you put another value in, the old one gets deleted forever. Evaluate first, then assign. And lastly, assignment does not connect variables in any way. In our language, JavaScript, which we'll be using, assignment is written as equals. So instead of this arrow, we simply write equals. Be aware this is different from a math equals, which means equals forever. So more means put this value inside this variable. So very different things. We just use the same symbol to mean them. All right, we took some time to investigate an app, which you can find in code.org under Unit 4, Lesson 2. Here you can see some very basic ideas that comes to variables. One important thing that you might want to do is you might want to make use of the watcher option in the bottom right, which allows you to keep track of a variable as you execute a program. Some interesting things to point out. This will be very easy to create a counter. So every time the ID is clicked, you add one to myvar. And this is how concatenation is usually used. You can have two separate variables appended together along with some kind of word in between, and all of that is allowed and would be stored in a singular variable over here, my story. For your assignment, you need to do lesson 3 inside unit 4. You need to go through all of the bubbles there. You can use watchers to see what your variables are doing. You can use console.log to help you figure out where things are. Something important to point out is summarized in this video right here. If you have a situation where you accidentally decide to put a value inside your clicks, but you put var in front of it, this will create a brand new variable called clicks. It will overwrite your previous one if you just have it out in the open. But inside an on event, it actually creates a completely brand new separate variable, also named clicks, distinct from this clicks. So be very, very aware. If you do this, you will not get the expected behavior. This is creating something called a local variable, while clicks over here is a global variable. We're going to talk about this a whole lot more later on in the year, but for now, please create your variables only once and keep them at the top of your program to make them all global variables. Global variables are permanent and can be used anywhere in your code, whereas local are temporary and it can only be used within the function they're declared in. In this case, this on event. But that on event is a very transient thing that happens just once when you click something, so this variable would not be very useful to you. That's it for today. We're picking up next time, continuing our discussion of variables, and we'll be moving on to more interesting things like functions very, very soon. I hope you have a great day, and I'll see you guys next time.